particular week. Wait, why I'm not cannot recording here? Oh, okay, started. All right. Okay, it's already started. Okay. So what we are going to have this week will be on the clustering. Okay, so what we have done some introduction about the clustering, if you remember. Okay, it was during uh back several weeks, yeah. I guess it's before the semester break, yeah. So we have gone through on some of the uh actually part of the similarities, and also part of what we call k-means algorithms, yeah. But I would like to recall, yeah, I would like to recall, okay, what are about similarity itself before we proceed on the hierarchical clustering. So this is the topic that we are going to discuss further later on. Okay, though let us have a look at what we have done before, yeah. So on the similarity, yeah, wait, why? Okay, let me go. Yeah, on the similarity. Okay, on the similarity, we should able to what we call understand on getting the similarity is based on, it should be done based on the data types. Okay, so that we have understand that in uh, constructing or in preparing the data set, we will have what we call as data matrix, yeah, where we have column and also we have records. Okay, and then the second part will be on the dissimilarity matrix, yeah. In clustering, we use dissimilarity matrix and the information of what we call um, uh, the value that we store in the matrix will be relevant to what we call as the um, distance. Yeah. So what is distance? Yeah. So you if you look at this dissimilarity matrix, it actually represented not by row and column like data matrix, yeah, but it's presented as objects. Yeah, objects versus objects. Meaning to say here, okay, we need to say here, the uh, column, sorry, the row is objects and the column also object, and this is the distance. Okay, so we have discussed about it, yeah, how we are going to get the value of the distance. Then we have to look at what we call the attributes. Okay, so in this slide, which is covered last time lectures, yeah. So we have looked at example some of the attribute. The first one is nominal, where the nominal will be based on the simple matching, and also if the data set consists of multiple binary attributes, then we have to create, or we have to follow some steps, yeah, is involved looking at the contingency table and so forth. Okay, let's just want to recap. Okay, for simple matching, okay, this is actually the distance is calculated based on the number of variable minus the number of matching attributes, okay, and divide by the number of variable. Okay, so here in this example, we have only one variable. Okay, this would be the dissimilarity matrix. Yeah, so I'm not going to show one by one again because it's been covered before. Okay, the next one is another example showing when we have multiple nominal attributes. Meaning to say here, the number of attributes P, yeah, the number of attribute will be changed to 2. Okay, and the number matching will be looking at the value of, yeah, the value of the what we call nominal, yeah. Let's say here the zone code and also the task code. So it should not be done separately. Okay, but it's actually have to look at how many attributes show the matching value, the matching value, yeah, and it's actually will be generated based on zone and task code similarity matrix. Okay, so again this one I'm also not going to repeat it again because it has been discussed, right? Like if we want to compare this and this, clearly is only one matching. Okay, this one is not matched, so the number of match is equal to 1. Okay, whereas T is equal to 2 attributes. Okay, you can try it again later on, okay, if you can't remember about it. Yeah, and we have binary attributes here. Okay, so binary attribute involves several steps which we have to create what we call the contingency table. So what is contingency table? Meaning to say we have to compare the object that involved in a comparison, which is object 1 and object 2. And then we have to look at, because this is binary, the states, there are 2 states, we convert it into 1 and 0. 1 is for example, positive, 0 is for negative, or 1 for yes, or 0 for no. So inside here, we will have Q, R, S, T. Okay, depending on the symmetry or asymmetry. Yeah, asymmetric what we call value or attributes. So if we deal with equal value or asymmetric value, then R plus S. Yeah, so the difference between R and S is counted. Okay, and the divider or would be QRST, the count of all. Okay, how about if asymmetric? Yeah, not equally important, then we have to consider um we have to consider the difference, which is referring to the count of R plus S, but in terms of the divider, we only consider the QR plus S. Yeah, QR plus S. Okay, yeah. So this is what we call as the distance, yeah, distance for binary. And then we also discuss about the next one is about, yeah, numeric, where we use Euclidean distance. Okay, in calculating the distance of numeric value is actually there are more formula that can be used, like Manhattan and Minkowski and so forth. But in our slide or in our subject, we are going to focus on using the Euclidean distance. So Euclidean distance, yeah, Euclidean distance can be seen here. This is the formula. Okay, and then this is another example for numeric. Okay, so where you refer to let's say you are going to compare between x2 and also x1. Okay, so the value would be okay, the value will be to compare between the value of attribute 1 and also attribute 2 for x1 and x2. So this is how we put it in the equation. Okay, so we have discussed about that, and lastly will be the ordinal, meaning to say in ordinal, the data or the value originally is a nominal, but it has rank, so it need to be transformed into numeric representation. Yeah, so meaning to say the data will be mapped. Yeah, the data will be mapped into the rank based on 0.0 to 1 value. Okay, so this will be the mapping. And when we want to find the distance of object, yeah, then we use Euclidean distance because the data is already in the numeric form. Okay, so overall these are the types of attribute that we have discussed. And lastly would be the textual data. So the textual data will be repeated in final topic later on, so I'm not going to focus on this one today. Okay, so these are the similarity, the similarity distance that been used in finding the difference or the distance between objects, yeah, in one particular data set or one particular what we call given set of objects. All right. So I hope that you can refresh, yeah, you can relate, yeah, you can relate what we have done last 2 weeks, 3 weeks, yeah, last 2 weeks before. Okay, so far any questions before I proceed? Do you have any questions on the similarity?
No question, Doctor.
Okay, all right. So if there is no question, then I will proceed with the second part, which is more important to be to be understood today, which is on the second what we call uh, algorithm. Yeah. So during last 2 weeks, we have discussed about k-means. Yeah, which k-means is actually a partitional method, yeah, for clustering, which the data will be divided into partition, different partition, and most of the time, the outcome of this partition would be no uh, non-overlap, yeah, no overlap within clusters to clusters. Okay, so that is one concept of clustering. Okay, so for today we are going to have a look at what we call as the hierarchical. Okay, so what is hierarchical? Hierarchical considered one clustering methods, and in this method is suggesting that we can have a look at the clusters, yeah, at the beginning, as not one cluster. I mean, at the beginning we will have a look at or we consider each of the objects as one cluster, yeah, and then whichever objects that similar, yeah, to each other, it will be merged. So it will start by comparing two objects to object and then find the similarity between these two objects. Okay, and this approach is actually work combined. Okay, when you have create several subcluster at the beginning of the cycle, okay, at the end you would see the outcome will be in the form of all is actually in one cluster. Okay, so as you see here at the beginning, you can see object 1 and object 3 is been merged, subject 2 and 5 is been merged, yeah, and the distance as you see, the first cluster is being merged because of the cluster is nearer to each other. Okay, and then it's been merged. Okay, the next one will be merged. Yeah, and you see this X is actually representing distance. Okay, so the first one will be the distance quite apa nama apa kata pendek, what we call ni lah small. Okay, and this is becoming quite big distance. Okay, and then if you look at the next cluster is being merged is within this cluster and another point. Okay, and then this is becoming one cluster and it will merge with this previous cluster, and until end all of the cluster is belong to one. Okay, so if you want to see if you, this is what we call as the dendrogram. Okay, and this is what we call as the nested nested cluster. Okay, so we are going to produce the outcome of this this clustering method will produce these two visualization. So most of the time when we do when we apply hierarchical clustering, we would have to understand the smallest ataupun the lowest hierarchy, yeah, of the objects until the highest hierarchy. Okay, so in hierarchical clustering, it's not only one method that I have discussed just now, this is known as agglomerative or AGNES. Okay. But there is another method. We started with the big cluster. I mean, all objects belong to one, and then we divide it into several subclusters. Or this is what we call the diversive or diana. In this particular subject, we are going to focus only one method, which is AGNES, yeah, agglomerative. Okay. So this is what I have discussed or I have been explaining just now. At the first point, it will be as individual, and then the algorithm will merge, yeah, will merge closest pair of cluster until all becoming one cluster. Yeah. Okay. So this concept, yeah, in this concept, it has been proposed back 1990s, yeah, and then under the hierarchical clustering, yeah, there is also a method to be understand, yeah. So we need to understand another concept in terms of how you want to merge, yeah, how you want to merge the points or the object inside the data set. This first method that we are going to discuss about hierarchical clustering will be known as the singling method. And definitely we are going to use the hierarchical metric as well. Okay. Right. And then the concept of merge, if you look at the merge based on the closest pair. Okay. So here, meaning to say least dissimilarity. Yeah, more similar to each other. Okay. If based on my explanation, I believe you can relate it to the basic algorithm over here. Okay, so previously I have shown you some of example of attributes, yeah, example of attribute in constructing the dissimilarity matrix. So here, if you look at the first step, you should understand that the algorithm will compute the dissimilarity matrix based on the given data set. Okay, and then it will assign, yeah, or it will treat each of the point as one cluster. Yeah, whichever closest based on the distance, yeah, based on the distance that we see in the dissimilarity matrix will be merged. Okay, after we have merged these points, then the dissimilarity matrix will be need to be updated. Okay, so at the end you are going to have a single cluster. Okay, why we need to update? Let's say originally you have 4 objects. Yeah, so because we consider or we treat it as one cluster for each, then it is 4 clusters. Okay, 4 clusters, right? So when we have merged or we have combined, meaning to say from 4 objects or from 4 clusters, it will become how many clusters? When we have merged 2 closest cluster. So what is the number of cluster? It become what? From 4, it will reduce to, hello, following or not? So after we merge, for example, 2 cluster. Okay, so meaning to say it will reduce to, this is 4 cluster, and then it will reduce to
2.
3 cluster lah. Yeah, you cannot, I mean, you merge 2 cluster. Okay, so become from 2 cluster, it will merge, is become a single cluster. So the remaining you have 2 clusters. So meaning to say it will be reduced to 3 cluster. Okay, and it will merge another 2 cluster. Meaning to say you will have the remaining 2 clusters. Okay, and then at the end, here, after you merge these 2 clusters, all becoming one cluster. Okay, so this is what we call as the algorithm over here. Okay, this example, when you have 4 objects only, which that you treat firstly as for cluster. Okay, still not clear, but it's okay. Okay, now we look at some of the example that we can produce after we perform, the uh, the hierarchical clustering. So we can produce this one. This is the one that we merge. Okay, this is merge. Okay, this is being merged. And then it's being merged together, and all is being merged, and until a single cluster. Okay. Okay, so this is some of the what we call analogy. Yeah, so you can see the the first steps, and this is intermediate step. Yeah, where intermediate step, and then you have to also merge, yeah, the clauses, and will need to update the dictionarity matrix. Okay, and and then the most what we call tricky step will happen here. Okay, after you have merged, and how you are going to update the metric. Okay, so we are going to discuss about that later on. Okay, before we go to that, then I would like to suggest for you to understand about getting or defining the inter-cluster similarity. Okay, so this is cluster 1, and this is cluster 2. Okay, as you see in cluster 1, there are several objects over here, and this is several objects over here. Okay, so if you want to combine the cluster, yeah, you can you can calculate the distance based on several function. Okay, you can calculate the distance based on the several function. So what are the function? First is minimum function. So what is minimum function? Meaning to say, you extract the distance of the cluster based on closest objects between these two clusters. If we talk about closest object, okay, right, as you see, this is cluster 1, this is cluster 2. What are the closest object? Clearly, in naked eye, you can see this is the closest object. Okay, right? And from here, you will get the distance value, yeah, when you perform comparison between object here and object here. Okay, the next function is max. Okay, what does it mean? Okay, what does it mean? If you look at the max, it's slightly different because we extract the distance based on the farthest object. Okay, so we want to find the distance of the cluster based on the farthest object. Okay, so here, yeah, here, if you look at the naked eye, you can see this is the farthest. Okay, how about group average? How about the group average? Okay, group average will be using all distance, meaning to say each of the object will be compared, yeah, with another object, and then, yeah, and then the distance will be divided to the number of pair. Okay, to the number of pair. So here is actually getting the average value. Okay, right? So object here, all object here will be compared to all object over here, and the distance of each of this will be average and will be divided. Okay, that is what we call as the average. Okay, next is the distance between centroid. This is slightly adapting what we call the k-means algorithm, because in k-mean algorithm, it will try to find the seed point, which is referring to the centroid. What is the centroid value? Okay, so here we have object. Okay, so how to get the centroid value? For example, we have here 2 4, apa nama, 2 4, the coordinates, right? And this is let's say this is 4 4 1 lah, okay, and then this is slightly like 5 3, and this is slightly apa nama, 3, okay, 3 6. Okay, so how are you going to get the centroids? How are you going to get the centroid? If you remember, centroid meaning to say it's x1 plus x4 divided by 4, and also y1 plus y4 divided by 4. So you have to get 2 plus 4 plus 5 plus 3, for example. Okay, and y is 4 plus 1 plus 3 plus 6. So you will get the centroid value. And then you compare centroid and centroid in cluster 1 and cluster 2. Okay, so that is how we define, or how we want to put, how we want to put the distance, inside the dissimilarity matrix. Okay, any questions? Any questions?
No
So
question.
far, so good, Doctor.
Not yet. Yeah, not yet. Okay, thank you. So what we are going to discuss today, we are going to discuss about these two functions only. Okay, right? So if we are going to discuss all, you will overwhelm. Yeah, so we are going to compare the methods of hierarchical clustering using minimum function and maximum function. Okay, so in that case, let's see the difference between minimum function and maximum function. Yeah, as I have explained just now, minimum is by looking at the distance or the similarity of two clusters based on the closest point. Okay, as you see, here is cluster 1, cluster 2. What are the closest point between cluster 1 and cluster 2? What are the closest point? Any idea? What are the closest point over here? Closest point. Yeah, 2 and 3. Yeah, betul. Okay. But as a computer, it's not like us, ada mata. Do not have eye to look. Okay, we can see here. So the difference is between 2 and 3. No. Okay. But in computer, the computer will do what? How? The computer need to calculate, to check, to check the distance for each object as well. So as you see here, see, what is the distance between this cluster? This is cluster 2, and this is cluster 1. Okay, so computer need to check, the distance between here and here, here and here, here and sorry. Okay, here and here and here and here. So distance of 3 and 2, and then distance of 6 and 2, and then distance of 3 and 5 and 6 and 5. Okay, and then the algorithm found, this is the closest distance. Okay, and then it will give information or give the output of 0.115. Okay, so based on minimum function, okay, the algorithm found the distance between cluster 1 and cluster 2 is actually 0.115. Okay, so this is using minimum function. Okay, how about using maximum function? How about using the maximum function? If you look at the farthest distance, what are the farthest objects? The farthest object will be here and here, right? Okay, but though again, computer need to run, to do and to calculate, to calculate each of me, then it will conclude the maximum. So I believe most of you already learned about fuzzy, kan, ataupun currently is learning about the fuzzy. So there is operator of min, operator of max. Okay, so And also in discrete mathematics, if you remember, in discrete mathematics, we learn about min and max as well. So same goes to this apa nama? In this concept. Yeah. So our algorithm, the algorithm will try to find but replace min to the max. So we can see that, okay, whether this is the fastest or this is the fastest. Okay, so we extract the value, okay, and then we will see that the fastest is 0.39. So what is the distance of cluster 1 and cluster 2 with maximum function? The answer is 0.39. Okay, right? So these are the two methods, two different methods using different function. Okay, so this is what we call as the single link and complete link. Okay, why we have to do this? Because of the concept of defining the cluster. Yeah, there will be many ways. Okay, there are many ways. So we can define the functions to be used in one of these. Okay, so okay, what we are going to discuss in this subject, only these two functions. Okay, hopefully it's clear. Yeah. Okay, so this is only considering one example, part of all. Yeah, part of all objects that we see in the data set. Okay, so we are going to expand more here. Okay, we are going to start with this one. Okay, so before you start, make sure that you have these so-called papers, yeah, or slides if you want to use the set as well, printed up, but make sure you have the paper. Boleh ya? You understand what I'm talking just now? How many functions that we are going to discuss today?
2.
How many functions? 2. Alright. The rest, boleh faham ke? Boleh angkat tangan, siapa yang ada?
Boleh.
Boleh angkat tangan? Okay. Right. Okay, good. Okay, good. All right, good. Okay, good. Those from University Telkom also, you can raise your hand if you are listening to me now. Okay. Okay. Yeah, half of you or third quarter of you have raised your hand. Thank you very much. All right. Okay, now I'm going to proceed with the second part. Yeah. So you can apa nama? Hand down lah. Yeah. Okay, raise down. Right. Now we are going to discuss about the first one. Yeah. With a bigger scope. Yeah. Bigger scope meaning to say to discuss on one example with several objects. Okay. The first one is actually quite clear because I think okay. All right. Okay. So this example where we have 6 points, yeah, 6 points, and then given this data in the numeric, yeah, in the numeric attributes, yeah, and it also can be represented and or can be visualized in the graph. Okay, so out of these 6 objects, okay, how we want to produce the hierarchy, the nested cluster and also the dendrogram. How we are going to produce nested cluster and dendrogram from the data set. Okay, so this is the basic algorithm that I have discussed just now. Okay, so when you extract the information from the graph, we have X and Y, and X and Y, I skip the process of calculating the dissimilarity matrix. Okay, I skip the process. But how you are going to calculate the dissimilarity matrix? How you're going to calculate dissimilarity matrix? Dissimilarity matrix is using what we call Euclidean distance function. Okay, this can be function. And you can see the example over here for point 1 and point 2. Okay, point 1 and point 2. Now, this mathematic can be apa nama? What we call has been calculated. Okay, has been calculated. This is this example for this one has been calculated, and this is will be the results. You may try later on if you want to confirm whether the value is right or not. Whether the value is right or not for each column. Okay. Now, from here, okay, the step 1 is that to find the two shortest distance. Yeah, two shortest distance. To find any of what we call combination. Any of the combination which is showing the lowest value. Okay, showing the lowest value. Right, so as you see, it has been highlighted over here in font, red font. So there are two lowest value here, which is 0.11 and 0.14. Okay, so we already can create what we call the dendrogram. Yeah, so 3 and 6 and 2 and 5. Okay, so here again, this is distance. Right, so how you going to get the distance values? So look at here, 0.11. Okay, and then look at here, which is 0.114. Okay, now this is what we call as the apa nama nested dendrogram. Okay, next from here actually, from here, can you draw the nested cluster already? Can you draw the nested cluster? What is the nested cluster? So you can draw like this lah. Wait, I go back to the previous slide. Just want to be precise lah. I just want to be precise, so I have to go to the previous slide. So it's between 3, 6 and 2, 5. Okay, so 2, 5 and 3, 6. Okay, right. So this is the first dendrogram from the iteration 1 and also the nested cluster that I shown just now. Okay, so now remember that after we have combined, because we combining two clusters. Okay, originally we have 6. Now you could see that the number of cluster has been reduced. Okay, because 2 is combined with 5, so it's becoming one cluster, and 3 and 6 is becoming one cluster. So the remaining 1 and 4. Okay, so we have reduced it into four columns. Okay, and also four rows. Okay, so the rest here we can use the existing values. Okay, and same goes this one also lah. No need to change anymore. But as you see, we need to calculate what is the distance. What is the updated distance between cluster 2, 5 and 0.1, cluster 3, 6 and 0.1 and so forth. Okay, so let us calculate it. Yeah. Okay, so this is the outcome just now. So now, okay, the idea is that after we form this one, yeah, we want to know the next one. Okay, what clusters can be merged? So there is a lot of possibility. we can merge this one, or we can merge these two. We can merge these two, yeah, or we can merge this. And lastly, this also can be merged as well. So which one? Then this is what we have to do. Okay, we need to have a look at the updated similarity matrix. Then we can decide. Yeah. Okay, from this original, this one, okay, which will be updated. Okay, so have a look on this process. Okay, you have to follow. So we have several value unsure. We cannot. We need to calculate. So it means that the distance of cluster C21 and 25 and 1. So here, because we are using minimum function, so minimum of point, sorry, 2, 5 and point 1. Okay. Okay. So now let's have a look at it, which is minimum of 2, 1 and 1, 1. Okay. So to the upper, let me see. Okay. Saya betul kembali. So we need to say here is the distance of, okay, sorry, mean of distance to 1 and then distance of 5, 1. Okay, right. So minimum of to 1 berapa? Look at the previous array. We have to look at the previous array. The value is 0.24. And then 5, 1, 0.34. So what is the outcome?
0.24.
Okay, 0.24. Okay, so you can replace this to 0.24. Okay, next we want to know what is the distance between cluster 36 and cluster 1. Okay, so mean of distance 3, 1, okay, and was and distance of 6, 1. Minimum of distance 3, 1, 0.22 and 6, 1. 0.23. So you will get 0.22. So here you can replace to 0.22. How about this one? How you want to do or how you want to perform this one? Boleh tunjuk. Can you do it for these three now? Okay. So those who get the answer, want to share the answer, you can put in the chat. Any answer for this value? Okay, good. Meaning here, mean distance of 3, 2, 3, 5, and 6, 2, and 6, 5. Yeah. So 3, 2, what is 3, 2? It's minimum of 0.15. Okay, yang dah siap tu boleh teruskan yang the rest ya. 35, 0.14, 62 is 0.25, and then 65 is 0.39 because we use minimum function, then the outcome is 0.15. Okay, good. Chahrul and also Ali Imran. Okay, how about this? Minimum of distance to 4 and distance of 5, 4. Okay. Then we will get minimum of 0.20 and also 0.14. Okay, so 0.14. Okay. Saya letak ni kejap-kejap. 5, 4 is here. See? 2, 9, 0. Okay, so this is 0.15, 0.20. Okay, so this is minimum of distance 3, 4. Okay, minimum of 3, 4, 0.6, and also 6, 4, 0.11. 0.11. Okay. So you can have a look at this and the outcome will be like this. Ada yang saya salah lagi. Okay. 3, 6, 3, 4. 0.16 and 2. Okay. Betul lah ni. 0.16 meaning to say in the slide tu have to be corrected. Yeah. Okay. 3, 4, 6, 4. Betul ke ni? 3, 4. Apa? So this is 2, 2. Okay, right. So here meaning to say which is the lowest. This is 0.24, this is 0.22, this is 0.15, this is 0.220. So I highlight the difference here. Okay. Here. Okay. Okay. So the answer, the lowest value of distance is within cluster 3, 6, and 2, 5. Okay. Semua dapat? Do you get the same answer?
Yes.
Yeah. So you can refer lah to the slide. The slide already there. And then we can see here, this is the lowest value, meaning to say we can merge the cluster and form. Yeah. This is the newly formed. And if you want to draw the nested cluster, it becomes like this. Okay. Yeah. So the next step is that, the next step is that this has been defined as one cluster, right? Okay. See, so we merge it into one column. Okay, so it's become only 3 columns and three rows. Okay, so we need to find this one. Okay, so how to define this one? Just now we have this, we have calculate this one or not? Not yet, right? So we are using what we call distance of 2, 5, and 3, 6. Yeah, this is already becoming one cluster. And apa nama? 1. Okay. So now we use range. So here to here and here to here. Okay. Distance of 2, 5, 2, 1. And then distance of 3, 6, and 1. Okay, here and 1. Sorry, here and here. And also here and here. So minimum of 0.24, 0.22. So what is minimum? 0.22. Okay, next is 1. For this is equal to distance of 0.25, 3, 6, 2, 4. Okay, minimum of 2, 5, 2.4, and 2, 5, 2, sorry, 3, 6, and okay. If you look at here, look at 0.16 versus 0.20. So the answer is, the answer is, berapa answer dia? 0.16. Okay. So now you can replace the value 0.116. So we have updated the similarity matrix. This mathematics have been updated. Can we define which one is the lowest? Here and okay. This is the way lah, this is the process, yeah. Okay. Any questions? Any question? Any more steps after this? Is there any more steps? Ada lagi, right? Okay. Selagi apa nama, we have several columns over here. We have to do another, or we have to process. We have to apa nama, enter another iteration, or we have to do the process. Okay, next it's like this. Okay, because we have already identified that this cluster has to be merged with this cluster. So as you see, this is the new form cluster. This is the value that we have calculated, right? Okay, so technically mean distance of, so it should be the distance of, okay, 0.25 3, 6, 2, 4. X. Sorry. Okay, comma 1. So it becomes like this. So this is to here, and this is to here. Minimum of sorry. Okay. Mana gambar dia? Okay, I didn't paste. Okay, so technically the outcome is like this. Yeah, 0.22. This one. This is the value. Yeah, and 0.22 versus 0.37. Then 0.22. So 0.22. Okay, so we can update the dendrogram, and it looks like this. Okay. Okay, so as you see, there are no more apa nama, you can put it as one big. You can update, sorry, this one, you can update the, after you get 0.22, so this is the lowest considered the ni lah, then we can update the matrix like this, so it's equivalent to 0, then it will terminate the process. Okay, and this is the updated of dendrogram. So at the end, the final cluster, nested clusters that you get seems like it will looks like this. Okay. Okay, and this is the dendrogram. Okay, any questions? Okay, if you have any questions, you can ask. Okay, the rest you can take for 5 minutes break before we enter the second one. Boleh ya? 5-minute breaks.